Okay, let's get started. We are going to jump into another area, the application developing using the database as a backend. Again, please, this is the link to the video. Watch the video, play the PowerPoint in animated mode. There is a class participation just for your own benefit. Try to answer the questions before you see them in the PowerPoint. There's an assessment and apply your work towards the homework your lab. So given the DBMS, this is the application software we are going to look into. So we are doing some programming using the database backend. Um, this is, for example, the Oracle DBMS, the layers of software. This is the disk where your tables reside. And this is a client process that's trying to access, so you are not using the command prompt, you are to program this to retrieve data from the database through the DBMS software. One example of DBMS is Oracle, but again, Microsoft SQL Server, MySQL, there are some other examples. So this is where your tables reside on the disk. So from the application, you are going to select, for example, everything from sailors. This is your table, and the information is going to be sent from the disk to main memory of the DBMS, and the result set is going to be returned to you. We are going to, this is what's returned from the DBMS software. Let's look a little bit closer into the memory. So if this is the Oracle and this is where you enter the SQL, inside the memory there's what's called a data cache. So the tables come from the disk and they are stored in the main memory. So and I'll show you the mechanism that allows you to access that memory. So what SQL is returning is a set, a result set. So it's not just a simple value. So it's a set of tuples that match the qualifications. These are some technologies that are used to access data sources, and like ODBC. Various vendors have provided drivers that allow applications to access their respective databases. Of course, you deal with versions and software changes. OLEDB, object linking and embedding database, it's another technology used, it's an API used by Microsoft. ADO.NET is another Microsoft technology, is using ActiveX data objects. Some XML. And JDBC is the Java, the Sun API. It's in the package java.sql. And I think it's a sort of a standard in how to access the database. This is another picture. You can see the applications from where you can access data sources. So data source can be Oracle, can be Microsoft, can be Access, can be MySQL. I would say basically any relational database. Please note that ODCB drivers have to be provided by those vendors, so these applications, client applications, can talk to it. This is an example where you can open Excel and you can import data source and you can connect to your database, and then you can pull the data and display it. This is how you connect to the Oracle. And then this is what you pull in the front end. So you pull table, the sailors table, and now you have that in Excel. You can go the other way as well. So these are the different technologies, different applications that use a database backend. So we'll look at some technologies and I'll give you some examples of using them. This is the ADO.NET, so it provides classes that actually match the table, and you can actually return columns and you can return the rows, so the classes are provided to make programming easy. They support XML as well. So let's look at what we are going to cover. First, we'll look at cursors. Which is part of the DBMS memory that you can access from your program. We look at SQL in application code, and there are 4 different versions. So I'll show you the JDBC, which is Java, the SQL J, how to embed SQL in host language, 3rd generation language, and dynamic SQL. So, and also you can write code inside the DBMS, and it runs inside the DBMS. So cursors. When you actually execute SQL commands, there is part of memory that is accessible to you. So if this is the DBMS server memory, right here, you have access to the cache. So let's say you returned a relation, and the tuples in that relation are available to you. So you can actually modify them, maybe step through them, insert, delete, or you can pull them into your application as well. So this is available through this concept of a cursor. So if this is your table, that's what you have access to. Let's look at the syntax. To create a cursor on a relation or a SQL query, which of course creates a relation, you can open it, you can fetch a tuple at a time, you can move the cursor until all tuples have been retrieved. You can order them as well, and you can, you have full access to that server memory, modify, delete, and so forth. So let's look at these 3 tables, and let's define a cursor called sinfo that gets the names of sailors who have reserved the red boat in alphabetical order. So let's look at the so declare sinfo cursor for. All these are, this is SQL J, so again, all these are keywords. So you are creating a relation, a table that has one attribute, which is sname, and is the result of joining sailor boat reserves, the condition join on SID, BID color is red, and order by sname. So this is going to return a relation with just one attribute, and the tuples will be order. Now you have access to that information through this cursor that you just declared right here. Okay, so this is the declaring the cursor. Let's look at stored procedures. So actually I can write code. If this is the DBMS, the stored procedure is code that runs inside the DBMS. So we'll look at some examples. The advantage is if you look at the cursor, to bring one tuple at a time into your application is very time consuming. So why not actually execute a code where the actual data resides? So you stay close to the data. So if your application is data intensive, you store procedures. If it's computational and intensive, then write the code in the front language. So these store procedures can be reused by many other times. So you avoid the cursor one tuple at a time return if you have a lot of data that you need to deal with. Let's look at some examples of store procedures. So create procedure, keyword, show non-reservations. Again, this is about the data. So I'm going to select SID, sname, and count from sailors, where the sailor ID in the sailor and reserves match, and I'm going to group them by SID, then by sname. This is a cursor. Now, store procedures can have parameters, and you have to use in, out, or in, out if these are input and output. So this create procedure, another one, increase rating, open, close parentheses. Here's 1, 2 parameters. Okay, so you put a keyword in. This is the sailor SID of type integer. This is in, increase integer. Let's look at the body. So what I want to do inside this procedure, I want to update sailors, which is your table, I want to set the rating plus increase, which is the argument you invoke this procedure with, where the SID, again, this is, you pass that as an argument when you invoke increase rating. So that's pretty cool. So the sort procedures do not have to be written in SQL. This is one that's written in Java. So again, keyword create procedure, top sailors, it takes one parameter, it's an input num integer, and you can specify the language is Java, and actually you can point to the file on your file system as well. Okay, so we created the store procedure. Let's see how we invoke it. So if this is the store procedure I created, this is how I invoke it from embedded SQL. So exec SQL begin declare section, all these are keywords. So what I want to do is to declare my variables. So int SID, int increase, and this is the end of the declare section. So instead of open brace, they use all these. So you want to actually increase the rating for this sailor, and you are going to invoke. So you exec call your increase rating, and you are going to pass the SID and the increase. This will execute and in the database, and voila, you are modifying that. Let's see how we invoke a store procedure from JDBC. Again, JDBC is Java. In Java, you have classes, and you create an object like callable statement. This is the object. Prior to that, you have to establish a connection to your database, and this is the object. And you call prepare calls. So the API calls, you have to understand what they do. And this will actually invoke the show sailor store procedure. So after that, you execute the query, and the result set is here, and you can use a while loop. This is an object, and the next will actually give you access to the return tuple one at a time. If I use SQL_J, the SQL_J, you have this pound SQL. I create an iterator show sailors, which is a cursor. And I'm going to invoke it by using call show sailors. Again, this is syntax. You learn how to actually invoke from embedded SQL, JDBC, SQL_J. After you execute show sailors, then you can actually go through the cursor, which is the memory in the DBMS, and by saying next, you get the next tuple and next tuple and next tuple. So this is how you invoke it. Now, the store procedures are written in a language, just like you have Java, you have JavaScript. This is called SQL PSM, Persistent Store Modules. But it's known in the Oracle is called PLSQL, in the Microsoft is called T-SQL. So it's a language like JavaScript. So in order to declare a store procedure, you use keyword create procedure. That's the name, and these are the parameters. You declare your local variables, and then you have the code. And to declare a function, you say create function. That's the name, and of course the function is going to return something. And again, the local variables and then the code. So let's look at, for example, a create function, rate sailor, that takes one input parameter, sailor ID of type integer, and returns an integer. We said we declare the variables. You have to use the keyword declare. This is the variable of type integer, declare numRes of type integer. So inside, I'm going to set the numRes. Please note that the result is going to be an integer, and is the result of executing select, count everything from reserves, where the reserves SID is the sailor ID that you'll pass when you invoke this function. After that, here's an if statement. If the numRes is greater than 10, then make rating 1. Else the rating is 0, else if, and if. And here's the return, since you are returning return rating. So I think we know how to program. So given this example, you declare the local variables. The functions will return a value. You assign, instead of just assignment statement, you have to use this set to assign variables. And you have branches and loops. So you have if condition, then statements, else if condition statements, else statements, and if. You have to use and if. You have loop and loop, so that's how you delimit your loops. Queries can be part of expressions, can use cursors, you name it. So you are just trained in how to use another language, PL, SQL, or T-SQL. Okay, so let's look at SQL in application code. Application code can be C, C++, or Java, and you want to either embed SQL or have an API that eventually will invoke SQL statements. Now, you have the host language like C, C++, Java variables, then you have the SQL data types. So again, it's first of all, you need, from the application, you need to connect to the database. And we'll look at two different approaches. So you want to either embed SQL in the host language, like embedded SQL and SQLJ, or you create a special API, which is basically a package like JDBC and some other vendors provide a package. So you create objects and they give you several methods that allow to connect, to execute query, to prepare query, to get the results back. So that's the second one, where you have an API that calls SQL commands like JDBC Java did. So let's look at an example. This is a JDBC, so your application speaks Java. So first you have to import the packages. You have to register the JDBC drivers. You have to open a connection to the database. You create a statement object. You execute a query, return the result set. You go through the result set, and at the end, please be nice, close the result set and close the statement object, and of course close the connection to the database. Now let's look at an actual example. So here's step number one. You import packages. JDBC is in the java.sql package. For other applications, here's your driver. So again, you have to make sure that you have the driver that goes with that particular data source. So here is your class example. Here is your main. You throw a SQL exception. So again, in Java, you have in that SQL package, you also have a SQL exception class. Okay, so step number two, you load the Oracle driver. So you have to invoke the method register driver, and this will be the driver, like this is an Oracle driver. You prompt the user, because you need to connect, you need the username password. So here's Java string user string password. You are going to read those, enter from the keyboard. And let's actually connect to the database. So connection is the class. You create an object and you invoke the driver manager get connection, and you, again, this is the server. It's an IP. That's the port. This is the username password. So to connect to a data source, you need the IP address, the port, and the credentials. So this user better have an account on that DBMS. So what I want to do now, assuming that this is correct, I want to, for example, query the hotel table for the resort Palma Nova. So let's create a statement object. So based on the connection object, I'm going to call prepare statement, and this is straight SQL. Select hotel name and rating. So my output relation will have two attributes from hotels, that's your table, where resort is Palma Nova. You execute the query. So here is the P statement, method execute query. And what you get back is a result set. So what I need to do next is go over the result set. So here's my while R set next. Again, it's going to stop when that returns false. So I'm going to take each tuple, and I can actually get to it by using rset.getString sub1 and getString sub2. So that's how I get the hotel name and the rating. And in this example, I just send them to the display, but I can do anything I want with them. And we are nice. We will close the result set, the statement, and the connection. So this is an actual JDBC example that from Java. So the language, the host language is Java. You can connect to a database, and through the API, you can actually execute and retrieve data from your data source. So these are the objects, but again, the Java.SQL provides all these. Okay, let's look at the second one, SQL-J. So I'm going to use this pound SQL. Okay, so in the host language, which is Java, I'm going to embed. So this is Java, string, bug, spider, and here's my pound SQL, open, close braces, semicolon. So what I'm going to do is embed SQL in Java. So this is insert into bugs. Name numlegs, the values. This bug comes from the host language, and actually the second one also comes from the host language, is the result of returning get numlegs on the bug. So when you use this column, that means those variables come from the host language. So SQL-J is SQL embedded in Java, and you can use Java as the programming language. And again, how do you actually make the call? So the preprocessor will actually convert these pound SQL to actual invocations. You can also do in C, Fortran, or other languages. So SQL-J is a standard, and simpler to use. It's an alternative to JDBC in case you are not very comfortable with that. So this is a standard. The specifications are for how you embed SQL in Java, how to write SQL routines, user-defined functions, stored procedures, the SQL data types, specification of using Java classes as SQL user-defined data types. So SQL-J complements JDBC. Compiler can perform syntax checks. All arguments are always bound to the same variable. So this pound SQL, these come from the host language when you use this column. So this is the pound SQL-J, and this is JDBC. So in JDBC, you use object dot and you invoke a method instead of using that. So this is an example of SQL-J code. So I'm in the front language, I'm going to declare SID, name, and rating. I'm going to create an iterator. So here's my pound SQL. So this is SQL iterator sailors that has 3 parameters. And I'm going to create an object of sailors. And here's again pound sailor. So what I'm going to return to, where this points to, is the result of select SID sname. So my output will have 2 attributes into SID and the name from sailors, where the rating is the one coming from the host language. Now, once I get the results back, I can say, while sailors object.next, I can actually loop through that. And again, this is the SID, this is the sname. So I'm retrieving what was returned to me. And of course, I need to be nice and close. So the iterators, which actually point to the memory location in the server, a DBMS server, where the either the table, the result set is you can have a named or unnamed iterator. So this is another example that when you define the sailors, this is a named iterator. Very good. Now, the data types. So you have application code, let's say Java, C++, C, and you have SQL, and the data types do not match. First of all, in Java, C, C++, you don't have a type that actually returns a set of tuples, which is what the relations will give you. And again, we have a mechanism to retrieve that information and parse it and assign that to from the host language variable. Now, let's look at the second approach. I'm embedding SQL in the host language. So a preprocessor will take these SQL statements and map them to API calls. So I have to use this exec SQL, like connect, exec SQL begin, or end declare section, exec SQL statement. So let's look at an example. Embedded SQL. So this is the declare section. Again, you have to write this keyword exec SQL begin declare section at the end, exec SQL and declare section. So this is I'm declaring C underscore S name, C SID, C rating, and C. There are two error variables that you have access to. One is SQL code, which is long, is negative if you have an error, but also you have a 6-character SQL state that gives you predefined codes to figure out what the problem is, like you cannot connect to a database. Now, this is an example for C, so I create SQL, declare SQL state. Here is the begin section for my variables 1, 2, 3, the name, min rating, and age. I'm going to call a random to get min rating, and I'm going to create a cursor, sinfo. Again, all these are keywords, exec, SQL, declare, cursor for. This is the only thing you choose. So my cursor is going to point to the result, two attributes of returning S name and SH from sailors, where the rating is actually greater than C mean rating, which actually should be in pink. It's add random. And also I'm going to order by S name, by the sailor name. Now, after I execute that, here's my do. And again, inside the loop, I'm going to fetch, again, exec SQL fetch from sinfo into the CS name. Again, this tells you it's the host variable, the CS name and CH. And again, this is C. Welcome to printf. So first of all, the C name, I'm using %s to print it. The second one is a float. I'm using %d. And again, this is the formatting string, and these are in the host language. These are my variables, and this will actually print. And you are going to loop through this while SQL state is not 0200, which is actually not found. So this is an example of embedding SQL in C. We have another version of dynamic SQL. So you don't know the queries at compile time, so you want, for example, to create them on the fly at runtime. So this rating will be actually entered at runtime, not at the compile time. So this is a different alternative. So database API, alternative to embedding. Instead of modifying the compiler, you add an API library like in the JDBC.SQL package. Very good. So this is the JDBC, which is Java API produced by Sun Microsystems. Very good. So let's look at the different data types. So this is SQL, and here is Java. You'll see that in Java, they actually created all the SQL data types. So let's see how we map SQL types to the Java types. So the SQL integer is directly mapped to Java int. The SQL char, varchar, long varchar is mapped to Java string. There are some unique ones. For example, the date, SQL data type, Java has created a date class, so you actually can map it to that. So this is the table, the SQL data type, Java class. So a bit is a Boolean. To get the value, you use get Boolean. The char is a string, so to get the value, use getString. So again, these are classes, and these are the methods that allow. In varchar, the same thing. The double maps the wrapper class from Java double, and get double will give you that value. This float, the same thing. It's a double. An integer is a wrapper class I integer, so you use the method getInt. Real, that's double, getFloat. The date, Java has a date class, so it's in the Java.SQL date, and getDate will return that. Time, they also created a class for time. GetTime will give you, and timestamp, they also created a timestamp in the package Java.SQL getTimestamp. So if you want to actually check for errors, you can use SQLJ, and it's done at compile time. But if you want, for example, to customize and write applications that you can deploy later on, you use SQLJ as well. So SQLJ is compiled. It's compiled. When we use JDBC, which is the API, when you use dynamic SQL, for example, the program builds queries on the fly, you do not want to have SQLJ at deployment. So these are some choices to use SQLJ or JDBC. SQLJ, so we know how to write programs in the database. So what's the difference between writing code in the front end, either using the API or SQLJ, or write the code inside the database? So the different applications, so use PL/SQL if the application is SQL/data intensive. And you use the Java if your application is computational intensive, not data. So these are the two choices that you have, and which one you are going to pick. But they are sort of doing the same thing. It's just a matter of efficiency. You don't want to do one tuple at a time. So if you have a lot of them, you would rather actually do that at the database level. Java.SQL also has the SQL exception class and the SQL warning class, and it's a subclass derived from SQL exception. And this is an example. Again, we are not going to use if error. We are going to use the try, and I'll show you the catch block. So for example, you are going to create a statement, and you can actually get a warning, and the get warning is the method you are going to use while there's a warning. So you can actually go through the warnings. You can clear them. You execute a statement. You again check for warnings. And here's the catch block for the SQL which is an object of SQL exception class. So you can actually handle the exception in the catch block. So this is an example. So you get connection, the URL, the DBMS URL, the login password. Here's create your statement. And here is your query. Again, this is a string, so I can put select name and rating from sailors. This is the result set after you execute this query right here. And then I can embed the going through the result set in a try block. So I'm going to loop through the result set. Again, there are two and I'm going to get the first one in S. I'm going to get the next one. I know it's an integer, right? So I can use system.println to print my the name and the rating. But please note the get string and the get integer. And this is the end of the try block, and I can have a catch block that will catch exceptions. So here is the exception handler, and in this particular complete example, I'm going to use the object, and I invoke get message, I invoke get SQL state, get error code, so that would be enough information to let me know what was wrong in maybe connecting to the database, maybe executing the query, or going through the result set. Another thing I can do is go and extract the database metadata. So the JDBC has a method get metadata, and I can get the driver name, the driver version. I can actually get information about my tables. So get metadata, I can get the tables, and here's the table name, and I can actually go in a while loop while next, and this is my tables, right? So I'm going to retrieve the first table, and I'm going to display it. So another thing, you can print the attributes of the tables. So you use the get columns, and these are the columns, and you go in a while loop. While there's some, you can call get string, and you can actually spit out the column names. So today we looked at application developing using a database backend, and we looked at embedding SQL in the host language. We looked at dynamic SQL. If your SQL you want to ad hoc, so you create the queries on the fly. We looked at the mechanism of a cursor, which is basically a reference to the DBMS memory that contains the result set. So with this reference, you can actually go and retrieve one tuple at a time, one record at a time. We looked at the JDBC, for example. That's an API that allows you to write Java applications that connect to the database backend. SQLJ is done at compile time. We looked at stored procedures. They execute at the DBMS level, so you are not going to bring one tuple at a time. You are actually returning the result that executes. So if your application is data intensive, you want to write stored procedures. The languages to write stored procedures: SQL PSM, known for Oracle as PLSQL, for Microsoft SQL Server T-SQL. Well, enjoy it. Apply these concepts towards the homework. Rewatch the video, and I think you'll be learning a lot, and you'll have the opportunity to write some programs using these technologies.